right, so now we're going to get into trigonometry. We're only doing the basics of trigonometry, and you'll learn more trigonometry at the high school level. But trigonometry is the branch of mathematics that deals with the relationships of sides and angles of triangles. And it was developed for astronomy and geography, but now it's also used in physics, engineering, and chemistry. So let's get started. A trigonometric ratio is the ratio of two side lengths of a right triangle. So in the diagram area, I'm going to draw myself a right triangle. I'm going to label the angles A, B, and C. And I'm going to label the side lengths A, B, and C. All right. So sine, you may have seen it like this. And actually in your calculator, it's written like this. And we don't pronounce it as sin, we pronounce it as sine. Sine is the ratio of a leg opposite to the given angle over the hypotenuse. So if I asked you for the sine of angle A, that would be equal to, looking at angle A, the opposite leg on your right triangle over your hypotenuse on your right triangle. However, if I asked you for the sine of angle C, you would then start at angle C, and we would do the leg opposite to angle C all over the hypotenuse. We do not do the sine of angle B, the right angle, because there is no opposite leg. The opposite side is the hypotenuse, so we shouldn't be doing the sine of a right angle. You could say that the sine of a right angle is 1 because the opposite side is the hypotenuse over the hypotenuse. So C over C would give you 1 of this 90-degree angle. Cosine, you may have seen it abbreviated like this. And that's actually how it is abbreviated in your calculator. The cosine is the ratio of a leg adjacent to the given angle over the hypotenuse. So, if I asked you for the cosine of angle A, this time we would start at angle A and we would take the leg adjacent or right next to angle A over the hypotenuse. If I asked for the cosine of angle C, we would start at angle C, take the leg that it's adjacent to or right next to, over the hypotenuse. Now, we cannot do the cosine of a 90-degree angle because if I start at angle B, which adjacent side do I want? this side or this side? I'm unsure. So we're not going to be doing the cosine of a 90-degree angle. And then our last trigonometric ratio that we are going to be learning, there's actually more than these three, but these three are the most common, is tangent. Also abbreviated as tan. Tangent does not involve your hypotenuse at all. Tangent is the ratio of a leg opposite to the given angle over the adjacent leg. So, if I asked for the tangent of angle A, you would start at angle A and we'd get the opposite leg over the adjacent leg. Whereas if I asked you for the tangent of angle C, we would start at angle C. You'd give me the opposite leg over the adjacent leg. So notice that the tangents of these angles are actually the reciprocals of each other. And we would not do the tangent of a 90-degree angle because the ratio of the opposite leg would be C, well, and C is not even a leg, over the adjacent leg. Which adjacent leg are we talking about again? So, we only are going to do sine and cosine of the acute angles of a right triangle. Trigonometric ratios are only used with right triangles. So if you're given a triangle that's not a right triangle, you cannot use these ratios. You can still do trigonometry without right triangles, but that's something that you guys will learn in high school. Now, it may be complicated to remember the ratios, so there's a mnemonic device that helps you memorize the ratios. SOHCAHTOA. So stands for sine, and that is the opposite side over the hypotenuse. Cos stands for cosine, and that is the ratio of the adjacent over the hypotenuse. And TOA stands for tangent, which is the ratio of the opposite side or opposite leg over the adjacent. So if you ever get confused, you can just repeat this to yourself to hopefully refresh your memory on what the ratios are. Let's get started. So it says to write each trigonometric ratio as a fraction. So cosine of A means we start at angle A. Cosine is adjacent over hypotenuse. My adjacent leg is 24. My hypotenuse is 25. So the ratio would be 24 over 25. Tangent of angle A is the ratio of the opposite leg to the adjacent leg. So 7 over 24. And then the sine of angle A is the ratio of the opposite leg, 7, over the hypotenuse, 25. Okay. So now we're going to do the same thing with angle B. We're going to start with the sine of angle B, which is opposite leg, 24, over hypotenuse, 25. Next, tangent of angle B is opposite over adjacent, so 24 over 7. And then the cosine of angle B is adjacent over hypotenuse, 7 over 25. Now looking at the ratios, it asks, what do we notice about the cosine of angle A and the sine of angle B? And then what do we notice about the sine of angle A and the cosine of angle B? They're the same. That is because the ratio or the angle that we have for angle A, if I did the cosine of angle A, that's adjacent over hypotenuse, whereas the sine of angle B, the opposite side in relation to angle B, is the same as the adjacent side in relation to angle A. Now, if you look at the tangents of both angles, they are reciprocals of each other, because same thing, the opposite side in relation to angle B is the adjacent side. So it makes sense that the fractions would be reciprocal of each other. All right, so for this next one, we're only given two sides of this right triangle. We need to find the third side by using the Pythagorean theorem, or in this case, this is a Pythagorean triple. So this side's just 15. So now we want the sine of angle C, which is opposite over hypotenuse, so 8 over 17. The cosine of angle C would be adjacent over hypotenuse, so 15 over 17. And the tangent is the opposite over the adjacent, so 8 over 15. I'm going to have you pause the video and try these three on your own. All right, and these are the three ratios you should get. Now this one says use the given trigonometric ratio to determine which angle of the triangle is angle A. So if we want sine, let's start with angle 1. Sine would be opposite over hypotenuse, so a 27 over a 30.6. They have the ratio as an 8 over 17. So if I do 8 divided by 17 in my calculator, I get about a 0.47. When I do 27 divided by a 30.6, I get about a 0.88. So these ratios are not the same. So angle 1 cannot be angle A in this problem. Let's look at angle 2 to see if that one works. Angle 2, opposite over hypotenuse. If I do 14.4 divided by 30.6 in my calculator, I get the ratio to be about a 0.47. So angle A in number 38 would be angle 2. Looking at 39, we want the tangent. So let's try angle 1. Tangent would be opposite over adjacent, so 27 over 14.4. They have the ratio coming out to be a 1.875. Let's see if we do a 27 divided by a 14.4. We do get a 1.875. So in number 39, angle A is actually angle 1. All right, that brings us to the end of your first trigonometry lesson.